All right, so on to our first example of special case solutions to inequalities. So starting with opposite inequalities, what can happen that is different from what we're typically used to dealing with. So first, we're going to solve it. So not going to spend too much detail describing that, as this has been described many times. The actual solving is pretty much very similar to everything that we've done so far, following your properties of equality, making sure you're doing everything, whatever you do, that it's logical, that you're combining like terms, but there's not really any different trick to dealing with this. So first thing I do is combine my like terms on my variables. Because I had variables on both sides, I moved my smaller variable. Now I'm combining my constants. 8 minus 15 is going to give me -7, and I'm going to get -7 is less than 7a. I'm dividing both sides of my inequality by 7 to isolate and find the value of the variable. -1 is greater than a, which is the same as a is less than -1. So if I'm trying to look at it the way that I'm typically used to dealing with, I want a is less than -1, because we're typically used to looking at this when the variable is on the left. So now I'm just going to go ahead and solve my other inequality. So first thing again is consolidation of the variable. I'm moving my smaller one, which in this case is the -14a, and I'm moving it through addition, which will give me 13 is less than 13 minus 11a. Then I'm going to move my 13 through subtraction, and in this case, what's going to happen is I'm going to zero out on both sides of my inequality, but in this case, 13 minus 13, I have to have a target, so that's equal to 0. So 0 is less than -11a, or positive 11a, sorry. That didn't work out. So that should be positive. So now I just have to divide by 11. But 0 divided by anything is still going to remain 0, so I have 0 is less than a, and again I have to flip this around. A is greater than 0, because 0 is less than a is the same as a is greater than 0, and now what that allows me to do is think about this situation. So to deal with special case compound inequalities, it's not about how you solve them, because the solving and the algebra is the same. It is about how you interpret the solution. So this case is telling me that in order for me to solve this inequality, I need to have a number less than -1 and greater than 0. That is not possible. You can't have a number that meets both of these criteria. That's the deal with conjunction compound inequalities. It needs to satisfy both pieces of our inequality. There is no way to do that. So what that tells me is that there is no solution. So now how do I graph no solution? I just draw a number line and don't do anything. So that makes it actually pretty easy to graph. So most of the time you're not going to be asked to physically graph a no solution yourself. You're probably most likely going to be having to pick this out. So this is most likely to be seen as a multiple choice question. So you just wouldn't graph anything. This is my graph of a no solution inequality, where I have opposite inequalities, meaning one is less than, one is greater than, and there is no way for a number to be both less than 1 and greater than 0. So no solution.